The Subcommittee on Environment will come to order. Good morning, everyone. Thank you for your time today. We welcome to today's hearing entitled Background Check, Achievability and New Ozone Standards. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witness panels, whom I'll be introducing in just a moment. The chair now recognizes myself for 5 minutes for an opening statement. Again, I'd like to thank our excellent witnesses for being here today. We have what is really a superb panel, including the head of my state's world-class Department of Environmental Quality. Welcome. And each of you, I know, intend to tell us about recent science related to the background ozone levels and how these developments should inform EPA's upcoming revisions in the National Ambient Air Quality Standards, or NAAQS, for ozone. Recent studies suggest that EPA may be underestimating multiple sources of background ozone, especially in the western United States. Failure to acknowledge these uncontrolled concentrations could lead to EPA setting a new ozone standard next year that is at or near background levels, with catastrophic economic impacts for large swaths of the country. As this slide shows, and this slide was created from EPA data, most of the nation would be non-compliant with new EPA standard. More discouraging, many of these locations would find it impossible to get in compliance because of naturally occurring ozone or from emissions that are imported from other locations around the nation, or in some cases from around the globe. In fact, EPA data suggests that areas in virtually every state would violate these standards if the agency went lower than the current limit of 75 parts per billion. The result leaves little room for states like Utah to demonstrate compliance with the Clean Air Act, and the consequences include draconian reduction requirements, severe economic sanctions, threats to highway funding, and construction bans. It's important to recognize that an unachievable standard would result in little actual environmental improvement. Over the past 30 years, the emissions of all precursors to ground-level ozone have dropped more than 50%. And states have not even began to implement the tighter 2008 ozone standards. The lower ozone standard of 60 parts per billion, which is currently being discussed by EPA, would be incredibly expensive. In fact, even the EPA's conservative cost estimate of $90 billion a year would make this proposed rule the most expensive regulation ever considered. But is this a record to be proud of? And it's potentially much worse, for outside analysis suggests the real cost of this proposed regulation is closer to $1 trillion in annual attainment cost and reduced gross domestic product. Recognizing the significant negative economic consequences of this proposed action, in 2011, the President showed restraint by withdrawing the proposal, citing the importance of reducing regulatory burdens. It is early in the standard-setting process, but once again there are troubling signs. The agency's Clean Air Scientific Advisory Committee, which advises the administrators on NAAQS, has already flagged that the EPA fails to provide a definition of ozone background or to discuss the role of background in developing options for the standards in its initial scientific documents. EPA also has signaled an unprecedented break with past practices in the Clean Air Act by attempting to disregard the background levels in evaluating health risks, essentially trying to load the dice to generate large regulatory benefits by claiming that the new standard would address ozone that cannot be controlled. One of the agency's own science advisors has called this shift a misinterpretation that invites litigation against the administrator and the agency. It is critical that these advisors carry out their obligation under the Clean Air Act to advise EPA of the relative contribution of ozone concentrations in natural as well as human activity, and to inform the administrator about any adverse public health, welfare, social, economic, and energy effects from the new ozone standard. It is very important that these scientists focus on their role as independent peer reviewers. But the reality that I see is concerning. For example, among the 28 panelists reviewing EPA's scientific documents in ozone, 22 of them are cited by the EPA in the agency's integrated science assessment, and they are referenced more than 1,000 times in a document they are being asked to critically examine. Our witnesses will testify today about new modeling and monitoring results that show the atmospheric events like stratospheric intrusions, transported emissions from Asia, and other sources could make new ozone standards unachievable. As we will hear, these results are confirmed by EPA monitors in rural areas and isolated national parks. And let me be clear. If EPA lowers its standards to 60 parts per billion, there are places in the country that could not meet it even if they eliminated all human emissions. An air quality standard that cannot be met in Yellowstone or Canyonlands or Zion or the Grand Canyon is simply divorced from reality. EPA claims that there are flexibilities within the Clean Air Act implementation that could resolve these concerns about compliance due to exceptional events or international emissions. However, the agency's track record on approving state applications under these provisions leaves little room for comfort. I look forward to discussing these absolutely critical issues with our witnesses today, and I now recognize the ranking member, Ms. Bonamici, for her opening statement.
Thank you very much, Chairman Stewart. I want to thank all the witnesses for being here today. I hope that this discussion about the latest science regarding the health standard for ozone in the air we breathe, how ozone affects health and our quality of life, will set the stage for a positive outcome. As we will hear this morning, the EPA is considering new scientific information that will inform their work on setting an ozone health standard later this year. The last time the EPA reconsidered the ozone health standard in 2008, the scientific recommendations of the Clean Air Science Advisory Committee called for a more protective standard than we currently have in place. Now, 5 years later, we know more about how ozone impacts our health than ever before. According to the American Lung Association, numerous health studies show evidence of a causal link between inhaling ozone levels well below the standard and measurable respiratory harm in children, the elderly, and people who exercise and work outdoors. Inflammation of the lungs and increased asthma attacks are just the start of the serious health problems associated with breathing ozone. Having a clean and healthy environment can build a stronger economy in many ways. Sick workers are not productive workers. Sick children are not learning and maximizing their potential. Time spent with doctors and in hospitals is time lost from more productive pursuits. And additionally, we cannot overlook the impact that pollution has on a thriving agricultural community. A vibrant economy can be the result of good environmental practices, not a victim of those practices. Over the years, scientific and technological advancements have dramatically improved our knowledge about how ozone is formed and where sources of ozone precursors originate. The majority of ozone in most parts of the country originates in local human activities. Emissions from power plants and tailpipes are often the leading culprit. But ozone can also form from precursor emissions that may have originated thousands of miles away, or from biogenic sources such as forest fires. Causes of ozone, especially at higher elevations and in the Intermountain West, seem to differ from those found on the east or west coasts and are often beyond the reach of our regulators. We still do not fully understand all of these complex processes, and strong investments in scientific research would make it possible for us to better identify sources, especially policy-relevant background conditions, with more precision. Scientific research would provide regulators with the information they would need to develop approaches to managing ozone more appropriate to local conditions. However, that kind of precision requires funding, and as Ms. Smith notes in her testimony, research funding at the EPA is under pressure, and neither states nor universities are in a good position fiscally to fill the gap. The EPA has the responsibility to ensure that its decision to set a new ozone standard is guided by the best available science. I'm cognizant of the argument that local conditions in the Intermountain West may require some new forms of flexibility by the EPA in enforcing ozone standards, and I encourage EPA to work with the states to develop such flexibility. Despite that call for flexibility, the science on ozone and health is sound. The need for more science on policy-relevant background levels of ozone must not deter or prevent the EPA from setting an ozone standard that is fully protective of human health. This country has proven time and time again that a cleaner environment improves worker productivity, increases agricultural yield, reduces mortality and illness, and achieves other economic and public health benefits that outweigh the costs of compliance. As we look ahead to the EPA's proposal to set a new ozone standard, the EPA must examine the latest scientific findings along with the cost of implementation and the protection of human health. I look forward to hearing from all of the witnesses, and with that, Mr. Chairman, I yield back.
Thank you, Ms. Bonamici. We now recognize the chairman of the full committee, the gentleman from Texas, Mr. Smith, for an opening statement.
Thank you, Mr. Chairman. Mr. Chairman, today's hearing comes at a critical time. The Environmental Protection Agency is now reviewing the science that it will use to determine whether to revise or retain the National Ambient Air Quality Standards for Ozone, called NAAQS. This decision has significant implications that will drive regulatory requirements across the country and will have a significant impact on the economy. In 2010, the EPA itself estimated that revised ozone standards could impose compliant costs of $90 billion. As we will hear from today's witnesses, the agency is now considering setting the NAAQS either at or below naturally occurring background levels in many parts of the country. This means two things. First, these areas will be out of compliance with the Clean Air Act through no fault of their own. And second, with no way to comply, these areas will face significant regulatory hurdles with little to no environmental benefit. A non-attainment designation under the Clean Air Act has serious consequences. Additional permitting and compliance obligations could halt any business expansion or new economic development. And with limits on federal highway funding, non-attainment areas would also suffer direct federal sanctions that will harm their ability to make critical infrastructure investments. The effects could be devastating. Looking at EPA's monitoring data, we see that if EPA lowers the ozone standards to 60 parts per billion, over 90% of U.S. population could live or work in a non-attainment area. Many communities still struggle to meet the standards that were set in 2008. In these tough economic times, tighter regulations would put an additional burden on the backs of hardworking American families. Businesses and communities across the country protested EPA's efforts to tighten these standards in 2010, and such concerns eventually forced President Obama to withdraw the proposal, a decision that is best remembered by former White House Chief of Staff Bill Daley's asking, "What are the health effects of unemployment?" I am once again concerned that without transparency, the EPA has incentive to further inflate the health benefit claims associated with tighter ozone standards. And alarmingly, the agency may exaggerate benefits using undisclosed data with highly questionable results. For 2 years, this committee has asked the EPA for access to the data that supports two federally funded studies, the Cancer Prevention Study and the Harvard Six Cities Study. This data's significance goes well beyond the ozone standards we now consider. It forms the basis for nearly all benefit claims from Clean Air Act rulemaking in this administration and a disproportionate share of overall federal regulatory benefit claims. In other words, the EPA has refused to provide the data that supports a majority of regulatory benefit claims. And the EPA has repeatedly failed to respond to congressional requests to make the underlying data publicly available. To the extent that any information has been provided, it contains significant gaps that make full replication and validation of the study's original results impossible. Further, these studies are decades old and have not been comprehensively updated. Even the National Research Council cautioned that these studies, quote, have little use for decision making, end quote. That the agency now attempts to use this data set to justify new onerous regulations is unjustified. Today I will send a letter to Acting EPA Administrator cautioning the agency not to rely on studies based on these data in the ozone rulemaking. I am also once again asking the agency to release the underlying data in a manner that is sufficient for independent analysis. If the agency continues to ignore this request, the committee will be forced to resort to formal action to obtain its release. Thank you, Mr. Chairman, and yield back.
Thank you, Mr. Chairman. I now recognize the ranking member, the gentlelady from Texas, Ms. Johnson, for an opening statement.
Thank you very much, Mr. Chairman, and thank you for holding the hearing on the forthcoming National Ambient Air Quality Standards for ground level ozone. And I want to thank all the witnesses for being here today. As someone who has been in the public health field, I'm keenly sensitive to the problem of poor air quality can have on the health of our citizens, and especially the young and the infirm. As a country, we need to do all that we can to ensure that we have clean air to breathe. The EPA is at the forefront of protecting our citizens' ability to breathe clean air. Whether it is in my home state of Texas or here in Washington, D.C. To do its job correctly, the EPA must invest in research, determining how pollutants occur and how they affect the health of our population. The EPA's investment in scientific research helps achieve regulations, which are the fairest and most cost-effective way of protecting our citizens from pollutants. I'm looking forward to the testimony from the EPA's witness here today to explain the science behind EPA's integrated science assessment of ozone and related photochemical oxidants. This report is another reminder of the importance in investing in research. If we're going to ask EPA to protect the public health and the environment, we must give them the funding to carry out the best research, thereby ensuring that the scientific justifications for any regulations from EPA are backed by the best science. It has always seemed simple to me that protecting the health of our citizens ensures a stronger and more vibrant economy. I look forward to hearing about these new ozone air quality standards from our witnesses. I thank you and yield back.
Thank you, Ms. Johnson. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. And at this time, I'd like to introduce our witnesses. Our first witness today, I'm proud to introduce her, is Ms. Amanda Smith, Executive Director at the Utah Department of Environmental Quality. She is responsible for providing leadership to the department and to the state of Utah to carry out DEQ's mission of safeguarding human health and quality of life by protecting and enhancing the environment. Prior to this, Amanda was a legislative director and rural advisor to Governor Huntsman. Amanda Smith received her law degree from Gonzaga University. And as our witnesses should know, spoken testimony is limited to 5 minutes each, after which members of the committee will have 5 minutes each to ask questions. I will introduce the subsequent witnesses as they get a chance for their opening statements. I now recognize Ms. Smith for 5 minutes to present her testimony.
Mr. Chairman Stewart, Ranking Member Bonamici, and members of the committee, my name is Amanda Smith. I'm the Executive Director of the Utah Department of Environmental Quality. Utah is fortunate to boast a high quality of life, a strong economy, and a safe, clean environment. Governor Herbert has directed the department to take a proactive approach to solve Utah's air quality issues, from a strong idle reduction policy for state vehicles to formation of an independent air quality organization, UCARE, to address statewide air issues, to a multi-partner state-of-the-science wintertime ozone study Utah has led. I'm speaking before you today to express Utah's concerns about how the state will meet the ozone standard if it is lowered from 75 parts per billion. Surprisingly high ozone values have been measured in rural monitors in Utah and even within national parks. Similar high values have also been seen throughout the Intermountain West. In Utah, our work to date has focused on reductions in urban areas, successfully reducing peak ozone levels to meet more stringent standards. However, in rural Utah, where there are few sources, ozone values have not been decreasing. Rather, values have remained fairly constant despite significant reductions in emissions of ozone precursors in Utah and upwind states. National efforts to reduce ozone since the 1970s have focused on the eastern United States and California, with the accompanying research, modeling, and regulatory strategies designed to solve those problems. The 1990 Clean Air Act amendments reflect that focus and included specific strategies and deadlines to solve an urban ozone problem that was primarily caused by mobile sources. Only recently, as ozone standards have become more stringent, has attention been given to background ozone in the Intermountain West. Recent research shows significantly higher impacts in the West than the rest of the country, with background ozone increasing every year. Wildfires and stratospheric ozone intrusions also contribute significantly to background ozone levels and have a disproportionate impact on the Intermountain West. It is critical to recognize that the primary causes of high background ozone are beyond the control of the states. Before moving forward with a more stringent ozone standard, EPA needs to have in place the necessary tools to allow states to succeed in meeting the standard. These tools could include legislation, regulations, technical tools, and additional research on ozone formation and mitigation. Additionally, EPA must define paths forward on how attainment will be addressed through policies such as the exceptional events, policy-relevant background, and rural transport area designation. Again, these tools were designed for the East Coast and currently are problematic and an ill fit for solving ozone in the rural Intermountain West. Specifically, the exceptional events policy has proven to be an impossibly high hurdle to meet and eats up literally thousands of hours of critical staff time to develop each submission. Since 2008, Utah has submitted 12 exceptional event demonstrations for particulate matter that have required over 4,000 hours of technical work. None of those have been approved by Region 8. There were many other events, including ozone levels affected by wildfires, we did not even attempt to demonstrate as exceptional events because the technical criteria are too difficult to meet. If the exceptional event process doesn't work for particulate matter, it will not work for the complicated science behind rural background ozone. If EPA moves forward with a more stringent standard without workable measures to address background ozone, it will guarantee failure for Utah, leading to severe consequences for the state. To put this in perspective, the Canyons Monitor in San Juan County regularly measures ozone above 70 parts per billion, the upper end of EPA's standard proposal. San Juan County is close to the size of New Jersey and has a population of about 14,000 people. If designated a non-attainment, permitting regulations would require existing sources to reduce emissions before new emission sources could be built, affecting economic development. If the standards are not met after that, more stringent strategies are required with additional reductions and activities such as achievable traffic control measures, etc. These requirements would be nearly meaningless in reducing ozone and would have an exceptionally burdensome impact on an area of Utah with one of the highest rates of poverty. The Department of Environmental Quality's mission is to safeguard public health and our quality of life by protecting and enhancing the environment. We take that mission seriously. Transportation-focused measures in small rural communities will not be effective, nor will overly stringent controls applied to remote sources. Setting an ozone standard that can't be met will not improve public health. Thank you, Chairman Stewart, Ranking Member Bonamici, and members of the committee. I appreciate the time.
Thank you, Ms. Smith. Our second witness today, then, is Mr. Samuel Altman, Research Associate with the Cooperative Institute for Research in the Environmental Sciences at the University of Colorado at Boulder. This is a joint institute between the University of Colorado and the National Oceanic and Atmospheric Administration. Mr. Altman's conducted atmospheric and environmental research for NOAA and its predecessors for nearly 40 years. And sir, you don't look that old. I find that hard to believe. And was the chief of the Ozone and Water Vapor Group of NOAA's Earth Systems Research Lab for 15 years. Mr. Altman's pursued graduate studies in astrogeophysics at the University of Colorado. And Mr. Altman's, for your testimony then.
Chairman Stewart, Ranking Member Bonamici, honorable members, my name is Sam Altman, and I'm a research associate at the University of Colorado. Thank you for this opportunity to present recent developments both from an observational and modeling perspective in our understanding of background ozone and its relevance in determining an ozone standard as part of the National Ambient Air Quality Standards process. In the previous review of the ozone standard, culminating in the current form of the standard with a maximum daily 8-hour average of 75 parts per billion, background ozone, or as was referred to as policy-relevant background, was based solely on an atmospheric modeling exercise from a single global model. At that time, empirical observations representing background ozone suggested levels higher than those determined by the model, but these were not given significant weight by the EPA and its Clean Air Scientific Advisory Committee in determining background ozone levels. As part of the review of the ozone standard currently underway, the Integrated Science Assessment refers to several terms to designate background ozone, including North American background and U.S. background. The term policy relevant background, or PRB, used in earlier discussions has generally been abandoned. This is a positive step in my mind, since it at least implies that background ozone can be assessed from relevant observations rather than being simply a model construct. Consideration of U.S. background reflects the reality that the U.S. has no regulatory control of pollution sources beyond its borders. Recent studies, including our own, have shown that several key sites at or near the west coast of the U.S. regularly provide observational data that represent background ozone levels. Two sites have been extensively studied that include Trinidad Head, a marine boundary layer site in Northern California, and Mount Bachelor, a higher altitude location in Oregon. At Trinidad Head, springtime daily 8-hour maximum ozone concentrations exceed 45 parts per billion 1/4 of the time. At Mount Bachelor, May ozone levels are higher than 60 ppb 25% of the time. These observations suggest that background ozone could be a substantial contribution at sites where ozone is measured near the NAAQS standard. I will show the recent model results also support this conclusion. In the current integrated science assessment, a comparison of the model-derived ozone values for determining background ozone for the assessment is significantly lower than the observed values, as you can see in the slide. This suggests background ozone is underestimated in the model, since at Trinidad Head, ozone levels under conditions representative of background are almost always higher than non-background conditions. Recent work led by Dr. Mayun Lin at the Geophysical Research Laboratory and Princeton University and collaborators, including myself, is a major advance within the modeling framework in the ability to quantify the contributions to background ozone. This new work by Lin and co-authors published last year dramatically reinforces the important contribution of North American background, including a significant stratospheric component on 8-hour average concentrations at or near air quality standard levels. Unlike the modeling work used in EPA assessments, the GFDL model explicitly simulates ozone variability in the lower stratosphere and its dynamic coupling with the troposphere, as opposed to using a parameterized formulation. Based on this model, estimates of stratospheric impacts on surface ozone over the western United States are generally higher and up to 2 to 3 times greater during intrusions than previous model estimates. This finding is in notable contrast to prior work concluding that stratospheric influence on surface ozone concentrations is rare. It should also be pointed out that these findings show that the influence of ozone transported from the stratosphere is not limited to episodes categorized as exceptional events. In summary, the work of Lin and co-authors shows that background ozone concentration contributes on average about 40 parts per billion to measured ozone in the Mountain West. A significant portion of the time, background ozone exceeds 50 ppb under high measured ozone conditions. Based on these recent results, the EPA and the ozone panel of KSAC should take cognizance of the underestimates of background ozone levels described in the assessment and utilize the more realistic estimates of background ozone available. These more realistic estimates should be used when developing the human health risk and exposure assessment, welfare risk and exposure assessment, and policy assessment documents that will play a role in the determination of the recommended ozone health and welfare standards.
Thank you, Mr. Altman. Our third witness today is Dr. Russell Dickerson, professor at the University of Maryland's Department of Atmospheric and Oceanic Science. Dr. Dickerson has served on EPA air quality panels and was a member of the National Academy of Sciences and National Research Council Committee on Animal Feeding Operations. Dr. Dickerson received his PhD from the University of Michigan studying radiation and trace gases in the atmosphere. And Dr. Dickerson, your 5 minutes, please.
Thank you. Good morning. My name is Russ Dickerson. I'm with the University of Maryland, but I'm speaking on my own behalf. I like this picture because it's the NASA P-3 research aircraft during Discover AQ campaign conducted over the mid-Atlantic states in the summer of 2011. And that picture was shot from the University of Maryland research aircraft. We have a Cessna. Our pockets aren't quite as deep as NASA's. But both of these aircraft were chock full of research instruments, and they're flying in formation at this point to make sure we're on the same page with respect to calibrations. In the middle of that picture, you'll see a little power plant on the eastern shore. So what's been the result of all of this, what we hope is policy-relevant science? Next slide, please. Oh, I can do it. These are the exceedance days over the past few decades for a combination of Baltimore and Washington. And you can see that we're making excellent progress. Why have we made this progress? I like to think that it's because the science has helped guide policy. And there should be some of these little lenticulars that look like postcards that have been passed around. They are NASA observations of NO2, the thing that produces ozone. And you can see from this lenticular that we've made good progress. The concentrations in 2005 were quite a bit higher than they were in 2010. So we're making good progress, but we're not there yet. You will notice that in the last couple of years, there are still a substantial number of exceedances in the Baltimore-Washington area. So my main point would be that ozone at concentrations of 60 to 70 parts per billion is harmful, causing morbidity and mortality. This is what the standard should be. It's the best science available, and that's my recommendation. It is absolutely true that natural processes, as my colleague Mr. Altman has indicated, are important. And as a research scientist, I've flown through these events and seen them. They happen. But I have never seen one in the eastern United States in my 20 years of flying through ozone events that has come down below about 10,000 feet altitude. So for the vast majority of non-attainment sites, these are not important. They are, however, important for the Intermountain West. Say, what is background ozone? This is an image. I'm an experimentalist, so I'm always skeptical of models, but some models are useful. And this is one that's useful, and it shows what the background concentrations of ozone are. How much ozone would we have if there were no emissions in America? And the hotter the color, the higher the concentration of ozone here. So this model makes sense with respect to observations. You can see that in springtime, there's a substantial amount of ozone, especially at high altitudes. In the summer, it's less. And if you look at the U.S. east of the Rocky Mountains, those concentrations are really pretty modest. So I think we can achieve higher standards. There is a mechanism in existence called exceptional events. I sympathize with the difficulty of getting those. The state of Maryland was successful in getting one. It was not easy. EPA has begun streamlining that process. Oh, and the NASA team, of which I'm a member, that generated these lenticulars, called the Applied Sciences, the Air Quality Applied Sciences team, is prepared to provide support at no expense to the states to help explain natural events, forest fires, and so on, using in situ and remotely sensed data. So that mechanism is in place, and that's appropriate for dealing with exceptional events. Now, for the eastern United States, certainly where I have most of my experience, there are certainly pollution sources that can be controlled. There are some power plants still using the technology of the 60s. ICI, industrial, commercial, institutional boilers that are uncontrolled, even agricultural processes that with judicious application and good agricultural practices could help reduce nitric oxide, ozone precursor emissions to the atmosphere. However, in order for these to be effective, we will have to realize that air pollution episodes are much larger in scope than a single small eastern state. We'll need to consider the entire eastern U.S. as one large airshed. So, in conclusion, I will say that I agree with tightening the standards. I don't think it's appropriate to punish the people of urban areas in the eastern United States by maintaining looser standards. We've made a lot of progress, but as Robert Frost said, we have promises to keep and miles to go before we sleep. Thank you.
Thank you, Dr. Dickerson. Our fourth witness is Mr. Jeffrey Homestead, partner of Brackwell and Giuliani. Mr. Homestead is one of the nation's leading air quality lawyers and heads the Environmental Strategies Group at Brackwell and Giuliani. He previously served as the Assistant Administrator at the EPA for the Office of Air and Radiation. He also served on the White House staff as Associate Counsel to former President George H.W. Bush. Mr. Homestead received his law degree from Yale Law School. Mr. Homestead.
Thank you. I'm delighted to be here this morning. As you mentioned, I'm a partner in the law firm of Bracewell and Giuliani, but I'm not appearing on behalf of my law firm or any clients this morning. I am here to share my views as a former EPA official and as a private attorney who spent more than 25 years dealing with Clean Air Act issues. One of the things I think has become apparent is ozone is not a new issue. There are some issues that arise under the Clean Air Act that really are kind of new. The focus on fine particles, which I know many of you are aware of, is something that really has only been a regulatory and science issue over the last decade or so. But ozone has been an issue now for more than 40 years. And I do think there's a couple of things, and I've been sitting here trying to think what I can add to this panel. And the first thing I want to say, which I think we would all agree with, is we really have made remarkable progress over 40 years. By any measure, ozone levels throughout almost, certainly all urban areas have improved pretty dramatically. You talk to people who lived in Los Angeles or Houston back in the early 70s, and it's really pretty remarkable. The issue, though, well, there's really a confluence of two or three things that are going on now. As researchers have become more sophisticated at looking at more subtle signals in the data, we are seeing that at lower and lower levels there appear to be health effects. There's still debate over how serious those are, how widespread they are, but certainly EPA over the years has changed its view on what the safe level is. So going back to when I first started thinking about these issues, the standard people were thinking about was 120 parts per billion, and that was measured in a slightly different way, so you can't exactly compare it with today's levels. But think of this, the standard has gone from 120, and then in 1997 it went down to 84, and then in 2008 it's gone down to 75, and now EPA is talking about lowering it. A standard that was 120 and then 84 and 75, we're now talking, as Dr. Dickerson said, somewhere between 60 and 70. The other issue is, so we've made enormous progress, but EPA says we need to do more, and clearly there is more that we need to do. The issue, though, is that notwithstanding this considerable process, the history has shown us that just changing the standard doesn't clean up the air. You need technology, you need things that you can actually do, and the way that the Clean Air Act works really hasn't changed since 1970 in terms of this particular program. Back in the 70s, the general view was if you had a pollution problem, it was largely a local problem, and so EPA would set the standard, and then states would be given the responsibility to go out and control local sources to make sure that they met the standard, and that's what people assumed was the way to clean up our air. Well, we've discovered it's actually much more complicated than that, as various people have talked about this morning. There certainly are localized sources of pollution, and I agree with Dr. Dickerson that there's more that we can do in some cases, but the problem is there are many parts of the country where there's not much more we can do, especially when it comes to these events that occur from time to time but don't qualify for EPA's exceptional events policy. And so my basic message this morning is I think that the Clean Air Act that has served us pretty well for the last 40 years on ozone is going to have to be reexamined. And I think that this committee, even though you don't have regulatory jurisdiction, can play a very important part in making sure that the public and policymakers understand the issues that we're facing today. I'd also like to suggest that we can rely more on EPA's Clean Air Science Advisory Committee, the CASAC, which was specifically set up by Congress to deal with some of these issues. And for many years, CASAC has largely simply responded to questions it has received from EPA staff. But Congress clearly envisioned a broader role for CASAC. And I think it is important now that we have very fine scientists who look at these issues about what is background, what more can we do in the United States, and then how do we deal with the fact that there are many states, certainly in the Intermountain West, but in other parts of the country, that now have a legal obligation to do something that is impossible for them to do. I hope that doesn't relate it to my testimony. Is that?
I think you're okay. Please continue.
So I think the fundamental question for Congress is what does it mean to have a statute that imposes a legal obligation that requires states to do something that is impossible for them to do? I don't think that makes any sense. I think it's contrary to our basic notions about what the rule of law should mean. And so I think it is time for Congress to start thinking about how we can be realistic about what we can do, how we can continue to improve air quality throughout the United States without posing the burdens on states like Utah and others that have really done largely what they can do and are being affected by events and by actions that are outside of their control.
Thank you, sir. By the way, none of us have any idea what any of those bells mean, so. Our final witness today is Dr. John Vandenberg, Director of Research, Triangle Park, North Carolina Division at the National Center for Environmental Assessment, U.S. Environmental Protection Agency. Dr. Vandenberg began working in EPA in 1984 and was responsible for performing national-scale exposure and health risk assessments for hazardous air pollutants. He received his Ph.D. from Duke University in biophysical ecology. Dr. Vandenberg.
Chairman Stewart and members of the committee, thank you for the opportunity to testify today. My name is John Vandenberg, and I'm a Division Director in EPA's National Center for Environmental Assessment in the Office of Research and Development. My division is responsible for identifying and evaluating the world's scientific literature to create the Integrated Science Assessment, which I will refer to as the ISA, for ozone. The ISA serves as the scientific foundation for decisions by the administrator on retaining or revising the National Ambient Air Quality Standards, which I will refer to as the NAAQS for ozone. My testimony today will include a brief overview of the process for reviewing the NAAQS, including how the ISA fits into this process, the scientific information related to background ozone levels in the United States. The process for reviewing the NAAQS contains four major components: planning, science assessment, risk exposure assessment, and policy assessment and rulemaking. The ISAs are developed by the Office of Research and Development to evaluate the atmospheric chemistry involved in pollutant formation and presence, as well as the human health and environmental consequences of exposure. The risk and exposure assessment, as well as the policy assessment, are developed by the Office of Air and Radiation, and they draw from the ISA, but they do not revisit the conclusions of the ISA. Each of these assessments undergoes independent peer review by the Clean Air Scientific Advisory Committee, or CASAC, and public review. The final stage of the NAAQS review process is rulemaking, which involves developing a proposed decision, considering public comments, and completing the review with a final decision by the administrator. Ozone is one of 6 pollutants for which a NAAQS has been established under the Clean Air Act. Ozone in the atmosphere is not directly emitted from sources, but rather ozone is formed in the atmosphere by photochemical reactions involving sunlight and certain air pollutants or precursors. Based on a strong body of evidence, in 2008, EPA lowered the NAAQS for ozone from the 1997 level of 0.8 parts per million to 0.075 parts per million. The current review of the air quality criteria for ozone was initiated in October of 2008. The final ISA for ozone includes the evaluation of over 2,200 scientific studies, and it was released in February of 2013 after 3 reviews by CASAC. The final ISA incorporated revisions based on CASAC and public comments. I have a copy here of half of the ISA. It's twice as much as that. In the February 2013 Ozone ISA, EPA concluded there is clear, consistent evidence of a causal relationship between short-term ozone exposure and respiratory health effects. EPA also concluded that the current body of research provides consistent evidence for a causal relationship between exposure to ozone and ecosystem effects. In the context of review of the ozone NAAQS, EPA generally defines background ozone in ways that distinguish between concentrations that result from emissions of precursor pollutants that are relatively less controllable from those that are relatively more controllable through U.S. policies or through international agreements. In the current review of the ISA defines background in 3 different ways. The most narrow definition is referred to as natural background, which includes ozone resulting from precursor emissions of only natural origin from all over the world, such as from wildfires and stratospheric ozone intrusion. A second definition is referred to as North American background, which is ozone concentrations that would occur in the U.S. in the absence of man-made precursor emissions in continental North America, including the U.S., Canada, and Mexico. The third definition is referred to as U.S. background, which includes natural background plus man-made precursor emissions from all countries outside of the United States, including outside of Canada and Mexico. Estimates of background concentrations in the U.S., regardless of which definition is used, cannot be obtained directly from measurements of ozone. Instead, air quality models are used to estimate background concentrations, and this approach has been supported by CASAC. The ISA included several recent modeling studies which showed that background concentrations vary by region, of the country and by season. These modeling efforts result in estimates of seasonal average North American background ozone levels of 29 plus or minus 8 parts per billion at low elevations. Modeling results also suggest that at high elevations, background concentrations can make up a greater proportion of measured ozone on some high ozone days. In low elevations, background concentrations make up a relatively small proportion of measured ozone on those high ozone days. These results indicate that at low elevation areas on high ozone days, that ozone is mainly formed in the U.S. from U.S. man-made emissions. In closing, EPA's Integrated Science Assessment for Ozone evaluates the scientific information on atmospheric monitoring and chemistry and on the health and welfare effects of ozone. This information will be considered by the administrator in the decision-making process for ozone. Thank you for the opportunity to testify today. I'm happy to answer any questions you may have.
Thank you, Dr. Vandenberg. I thank, again, all of the witnesses for your testimony. I'd like to remind members that committee rules limit questioning to 5 minutes, and the chair will at this point open the round of questions, and the chair recognizes himself for 5 minutes. Once again, I think that your expertise and the experience that all of you bring to this panel, we greatly appreciate that. Some of you know that I represent the state of Utah. Salt Lake City is a big part of my district. It's one of the most beautiful cities in the country, I believe, right at the foothills of the Wasatch Range. But because of geography primarily, we from time to time have inversions come in the winter, and ozone becomes a real problem for us. I have children. Some of them have respiratory illnesses, which was aggravated by these conditions. Ms. Bonamici mentioned in her opening statement children's health, and I appreciate that she did that. This is something that all of us would like to address. It's something that all of us would like to make better if we can. And Dr. Dickerson, you talked about some of the progress we've made, and as well as some of the other witnesses, and we celebrate that, and we should be proud of that. And I think most of us would agree that we want to help. We want to make this better if we can. Dr. Dickerson, you said something I'd like to come back to in a moment for a question, but you said, paraphrasing, I think, you said it's not fair to penalize eastern communities or some eastern states with a standard that would, if we were to lower that standard, would help those communities. And I would suggest that at the same time it wouldn't be fair to penalize western communities or western states with a regulation that is unachievable for them. If I could bring up the slide that I used in my opening statement, and I know this is familiar to all of you, at least I'm guessing that it would. You can see that vast swaths of this nation that would be either not in compliance with a new standard. If the EPA sets a standard of 60, 70 parts per billion, as they've been discussing, would any of you, I'll ask this individually very quickly, would any of you disagree with the statement that there will be parts of the country that cannot meet the new standard due to background concentrations of ozone? Ms. Smith, I'll start with you. Would you disagree with that?
Thank you, Chairman Stewart. No, I would not disagree with that. I think Utah's case in point, we would have counties that would be unable to achieve the standard.
Okay, and if I could emphasize that for just a minute while I'm talking to you, Ms. Smith. I mean, if you look at the map of Utah, and Utah isn't New York City. These are very rural part of the country. And you can see some of the eastern and southern parts of my state where there are a few thousand people living. And the ozone that's created there is very small, very, very small parts of that are created by man-made activity.
That's correct. If you look at the state of Utah, the lower southeastern county is San Juan County. That county has one major source.
Yeah, one.
One.
Thank you.
So it is an
Other members of the panel, would any of you disagree with that statement that there will be large parts of the country that would be in noncompliance because of naturally occurring ozone? Okay, so none of you disagree with that. Well, then I would ask very quickly, and maybe I'll start with you, Mr. Vandenberg, and I'd like to save a little time to come back to Dr. Dickerson, but I mean, what would those counties do? What do you suggest that they do then?
Thank you for your question. To go back to the question just before, you were asking whether background itself would lead to non-attainment in some counties. Is that?
Yes.
I understand what you were saying?
Uh-huh.
Okay, I have to say I'm not sure if it would be the case or not. The way the monitors are evaluated is to look at the fourth highest level in each of 3 years and average across those years. So I'm not aware of the data that would lead me to the conclusion to say yes to that. I apologize for
Okay, other members of the panel, would you think, Mr. Homestead, would that be true, that there will be some parts of the nation that would be in non-attainment because of background ozone?
I think that's almost certain to be the case, that
Okay.
yes, given the way the standard is currently done.
Okay, so let's assume that that's true, because that's the testimony of some, and our information indicates that's absolutely the case. Then again, Dr. Vandenberg, what would you suggest those parts of the country do?
I believe that the key thing is to bring to bear the science information that's available. As I mentioned in my testimony, a critical form of ozone is formed from precursor emissions from volatile organic compounds and nitrogen oxides, and is to look at the models to help evaluate what are the major contributors to the ozone at different levels. I recognize that there are stratospheric intrusions as well as wildfires that contribute, and has been mentioned, there is the exceptional events policy that may contribute to the evaluation of that.
Okay, and I appreciate your answer, and if my time is up, and I wish it wasn't, because I'd really like to come back to Dr. Dickerson, but maybe we'll have a second round. But I mean, for all of us, there is this, and it's worth repeating. If you are in a part of this country that cannot achieve compliance, and there's nothing you can do about that because of naturally occurring ozone, and yet the economic consequence of having to comply with an unachievable standard and the frustration that would create on the parts of many people, that's certainly something that I think all of us would appreciate and be sympathetic to. My time has expired again. I hope we come back for a second round. We'll see how it goes. I now yield my time to the ranking member, Ms. Bonamici.
Thank you very much, Mr. Chairman, and thank you to all the witnesses again for your testimony. Dr. Vandenberg, it's my understanding that the ISA review for ozone is one of the most extensive studies to date conducted by the EPA. You said you have half of it with you. It's voluminous. Could you briefly discuss some of the recent evidence that demonstrates the harmful effect of ozone on human health?
Thank you very much for that question. There is a significant amount of new studies that build on prior studies regarding the health effects of ozone. These include hundreds of epidemiological studies of populations throughout the United States and the world. It includes controlled human exposure studies. It includes toxicological studies, atmospheric sciences study, human exposure studies. There's a tremendous body of evidence. As I mentioned in my testimony, there are over 2,200 studies that have been conducted that are included in this ISA, and this is only half of it. And over 1,000 of those studies are on health effects. So we have the great benefit here of tremendous scientific weight that underscores the nature of that evidence. And what's very clear about it is it's very clear and coherent. A lot of the data, it fits together very nicely. We've got consistency in the results in terms of respiratory effects caused by exposure to ozone. And it is clear to me that with our Clean Air Scientific Advisory Committee that there is a strong endorsement for the strength of that science and how it can help inform ultimately decision-making that will be down the road.
Thank you. And you mentioned in your testimony about the 3 definitions for defining background ozone. Could you talk a little bit more about that, expand on that, and how did this approach aid in analyzing the scientific literature for the review?
Again, thank you very much. I think as the science has evolved, and as the other witnesses noted, in the last 40 years we've had tremendous advances in terms of both air quality management programs, but the science that underlies that. And in this document, the Integrated Science Assessment, what we've done is we've recognized that a broader set of definitions may be informative as we move forward. So we've brought into bear this sort of idea that you look at the world's background influence in the United States, you look at the North American background, which includes Canada and Mexico, and you include just North America, or just the United States, excuse me. So what that does is it gives us more information, and I think a key feature here is we want to be as inclusive as we can in terms of information to bring to bear as we move that into the decision-making process.
Thank you. And Dr. Dickerson, thank you for your testimony. You talked about how you've worked on the exceptional event process and the issues with the state of Maryland. And you also mentioned in your testimony you offered some assistance to states in this exceptional event process. I wonder if you could discuss a little bit about what you're offering and what assistance might be available to states as they go through this process, which Ms. Smith noted in her testimony was onerous.
Thank you. I am sympathetic. It took quite a bit of work for the state of Maryland to get its exceptional event approved. The NASA ACAST, Air Quality Applied Sciences team, has a number of scientists around the country who are very clever at using satellite information and other NASA information to help identify natural events or forest fires from both space and in situ measurements. For example, in answer to Mr. Stewart's question, what would you do if there were a tremendous amount of ozone above 60 ppb at some beautiful, and I agree completely that Utah is a spectacularly beautiful state. I love going hiking there. And if you're on top of a mountain and the ozone is above 60 ppb, the answer to that question is if you can monitor with commercially available instruments that have a proven track record other pollutants, other trace gases, like carbon monoxide comes out of tailpipes or oxides of nitrogen. And if the ozone is high and those other pollutants are not high, this is not a controllable event. It's probably a natural event. We know how to identify them. And that's pretty good, pretty conclusive scientific proof that this is not a controllable ozone occurrence. So that's what I would recommend.
Thank you. And I want to go back to Dr. Vandenberg because there are concerns raised about the inability of states to comply if the standard is lowered. Do you believe that the new definitions, or these 3 definitions plus the exceptional event process, could result in states being able to comply even if the standards are lowered?
I think one of the recognitions that we have is that the process of standard setting and then implementation are sort of phased. First, we set the standards, then we implement them. A lot of information is brought to bear there. I don't think you can speak to a particular situation as to what would be the approach that you would use, and I think the strength of our science is that we have a variety of tools that we can apply to help evaluate the types of events that are occurring. The key here is to use the science to its best advantage.
Thank you, and I see my time has expired. I yield back. Thank you, Mr. Chairman.
Thank you, Ms. Bonamici. And Mr. Dickerson, thanks for answering that question. And if I could just comment quickly regarding that, you took a very reasonable response to that, and I would hope that would be the case. But my fear is that the regulations wouldn't allow for the latitude of looking at what was naturally versus what was man-made, and that the control or the some of the mechanisms would kick in that would, again, not allow for the latitude that you described, but we could talk about that after, perhaps. We now recognize Mr. Weber for 5 minutes.
Thank you, Mr. Chairman. Mr. Dickerson, I want to go back to something you said in your testimony, and I didn't catch all of it at the time. You said that some of the ozone occurrences that you saw were above 10,000 feet.
Yes, if we've flown aircraft over the eastern United States, and you can see what are called stratospheric intrusions. That's a fancy expression for just natural ozone coming down from the stratosphere. And you can identify it by high ozone, but it's very dry and there are no indications of pollution in it. I have never seen one of these reach the Earth's surface in the eastern United States, though. I would love to. It would be very exciting. I'd probably ask my colleague Sam to help me write a paper on it.
Okay, sounds like you might be a little bored at times, I'll tell you. You said that they didn't occur except, they weren't substantial except out west. So those don't occur very often in the east.
They are more frequent at high altitudes in the western United States.
In the
That's
west.
correct.
Okay. And then I'm going to follow up on what you said earlier about assistance to states. Let's go back to that scenario for a minute. And before we do, if I remember correctly, a lot of the NOx gases, according to the EPA's own admission, or dare I say emission, they come from 70% of those come from non-stationary point sources. Is that correct? Or maybe that's a question for Dr. Vandenberg.
No, I can address that.
Okay.
In the U.S. as a whole, I think about 40% from vehicles, and the remainder, there are a lot of power plants and boilers, and then a number of small sources, including agricultural.
But non-stationary, you're saying it's only 40% of noxious gases come from non-stationary point sources?
The single largest source of oxides of nitrogen in the U.S. is now, according to the EPA estimates, tailpipe emissions from vehicles.
Okay. And so basically, can you explain why it is that in the Northeast, where there's a higher concentration of people and probably more vehicles, why there's less concentration there than over in the West, in the central part of the country?
Okay. I think your question is, why is there more NOx in the Northeast than there is?
Why isn't there? If
Oh, isn't
more
there?
people?
There is. If there's a picture, will show you concentrations
Okay.
of NOx are higher, certainly in urban areas than in rural areas, and they're generally higher in the eastern U.S. than excluding California, than in the western U.S.
So due in large part to a lot of the vehicles, you would say, but you're saying only 40%.
They're an important source, absolutely.
Okay. You said that in one of my colleagues' questions, assistance to the states, that if there was an event that was identifiable, you could provide assistance to the states, and then you said it's not a controllable event, it's a natural occurrence.
There are natural occurrences such as stratospheric intrusions. These are identifiable from the meteorology. Sometimes they can be seen from space, and if a full air pollution monitor were there, it'd be easy to pick them out.
So are you suggesting that on a real-time basis, the federal government would get involved and interact with the states and say, we have this event going on, and we need to send you some assistance to take care of it?
I don't know about the real-time part, but certainly there are ongoing efforts from me and my colleagues at the University of Maryland and another couple dozen universities around the country where we use NASA observations to identify
well, it scares me
fires.
when you get the federal government involved with the states because we're fixed to put more regulations on them. Strings come attached with everything that seems like the feds tell the states to do. How often do those occur? Once a year, twice a year, every month, every day, every week?
Forest fires are extremely common and identifiable.
So you're basically describing what's happening out west, and I'm running out of time here, so forgive me. Let me jump over to Dr. Vandenberg for just a second. You said, Dr. Vandenberg, in earlier testimony, it scares me a little bit because it doesn't seem commonsensical. Of course, let me just be sarcastic for a minute. I think when it comes to common sense, the EPA may be in non-attainment. Okay? You said first we set the standards, and then we implement them. Wouldn't it be commonsensical to have a stopgap measure that says, what effect does this have on industry? What are we fixing to mandate? That's a Texas term, fixing. What are we fixing to mandate on industry? And are we fixing to drive everybody's cost of fuel, heating oil, electricity, and everything sky high because we're going to mandate on the industry? Shouldn't that be considered, Dr. Vandenberg?
Thank you for your question. The way the Clean Air Act is constructed is I think that science is brought to bear to set the standards, and then the states are evaluating their air quality conditions and developing state implementation plans in order to attain those standards or maintain the air quality that's necessary. So I think it's the relationship between the Clean Air Act and the process is it's develop the standards and then work with the states, state implementation plans, evaluate the monitoring data, look at the sources as you were just discussing, and then determine the appropriate approaches that would lead to attainment and maintenance of acceptable air quality.
Well, there's a lot more I could say, but, Mr. Chairman, thank you. I'm out of time. I yield back.
Yes, you are, sir. Thank you, Mr. Weber. And now Mr. Takano.
Thank you, Mr. Chairman, and thank you to our witnesses for sharing your expertise today. Clean air is an issue that is vitally important to my constituents. I'm reminded of it every time I enter this committee room, and I look over to see the portrait of former Chairman George Brown hanging above me. Congressman Brown represented parts of Riverside County in my own district during his 34 years of service in the House, and during that time he was a champion for science and fought to improve air quality for millions across the country. He was an early supporter of the legislation creating the EPA and worked to include ozone provisions in the Clean Air Act. It's because of leaders like George Brown that we've seen air quality in Southern California make great improvements. Growing up in Riverside, I remember days where we couldn't go outside for physical education class because the smog was so bad. Days where you couldn't even see the mountains. In the 1970s, the ozone levels in Southern California exceeded federal health standard levels more than 200 times out of the year. And thanks to a lot of hard work and coordination between federal, state, and local stakeholders, we've cut that number of days in half. Guidance from EPA has been and will continue to be a crucial component of efforts to improve air quality in Southern California, and I'm glad to learn more about the process of these standards today. My first question, Ms. Smith, do you can you tell me about your background, your academic training? Do you have any degrees or undergraduate degrees or advanced degrees that are scientific in nature?
I do not. I have a degree in political science and history and law.
And so your assertion today that there are parts of this country that could not meet these standards, is that an evaluation based on science or based on the background training that's more political and legal in nature?
That's actually an assessment that's based on the 100 of air quality scientists and engineers that work for the Department.
But you yourself do not have academic background in science.
That's correct.
But you're here as an expert witness to offer a scientific, or is it a scientific or a political assessment?
Actually, I was asked to come and give a state's perspective on the policy implications, excuse me, and the ability for the states to actually implement and create a plan to address
Thank you very much. Mr. Olmsted, can you tell me whether or not you have any scientific advanced degrees or undergraduate training?
No, and I don't purport to do that. My role in this meeting, as well as in much of my career, is to deal with regulatory policy and how it works. And so that's my view here this morning, is to talk about how the Clean Air Act works from a regulatory perspective. And so I rely on others, and I think all of them have agreed that there are sources that cannot be controlled in the United States that contribute to a large share of the problems that we have here. So I don't think there's any scientific dispute about that. I think the question is, well, what do you do once you recognize that those are the data?
All right. Dr. Vandenberg, you believe that that the major basis on which we should establish levels of ozone that are acceptable should be based on the science concerning what ozone does to the health of the public. Is that right?
Right. There is a tremendous body of evidence, scientific evidence, on the health and environmental effects that ozone produces with exposure.
And it points to the level of 60 parts per billion. Is that right?
Again, I'm not going to speak to the specifics in terms of a level, but the scientific evidence does go from higher levels down to 60 and below. We look at the entirety of the exposures that are occurring. Some are relatively low, some are relatively high, and we look at the relationships between those exposures and effects.
Do you agree or disagree with the chairman's assertion that parts of this country could not comply or would not be able to attain these ozone standards as proposed? Or is the scientific evidence somewhat inconclusive?
What I'd like to say is, as I understood the question, was whether the background levels of ozone would lead to non-attainment areas, if I'm correct about that. And that's where I'd have to say we'd have to look at the modeling that has been done, as well as consider those exceptional events that occur to make those judgments. I can't say that there are any places that would not meet the standard specifically because of background levels. Background contributes to the ozone, but on top of that is the human-derived emissions.
Thank you. Mr. Dickerson? Same question.
There we go. I do not know conclusively if there are areas that would fail to meet a 60 ppb. There are certainly areas in the western United States where it might be difficult.
Okay. But, Ms. Smith, you categorically believe that there would be.
Based on what we've looked at in terms of the monitoring that we've seen coming from the state of Utah, there are counties that would not meet the 60 ppb from past history.
Okay, I've heard the scientists be inconclusive, but you are absolutely certain?
Yes.
Thank you.
All right, thank you. Before we go on, I'd like to note that I was very clear in my questioning to the panel. I gave you each the opportunity to say, do you disagree with that assertion? And none of you spoke up at that point. Hearing something slightly different right now, which, again, we may follow up with additional written questions. The full chairman, Mr. Smith, then. We give you your 5 minutes for questioning.
Thank you, Mr. Chairman. And let me apologize. I'm having to shuttle back and forth between this committee and another committee I sit on, which is marking up 2 bills. So I'm trying to vote in one place and ask questions in another. And if these questions have been answered, let me know and we can go on. Mr. Homestead, let me address the first couple of questions to you. And first is this. Of the 28 members of the Clean Air Scientific Advisory Committee Review Panel for Ozone, 22 of the 28 are cited by EPA in the integrated science assessment they have been asked to review. Is this consistent with the requirement in EPA's peer review handbook that, quote, an independent peer reviewer is an expert who is not associated with the generation of the specific work product, either directly or indirectly, end quote?
I have to say I'm not entirely clear of how EPA's regulations work. I think people have raised legitimate issues about the need for people outside of this little community to be involved in the process, but I can't say whether it's a violation of the peer review requirements.
Okay, it seems on the face that it probably is if you go by the common definitions involved, so that'll just say that that's my opinion, and look forward to hearing more about that from the others. My next question, though, to you is the EPA appears poised to rely on a single study to establish a link between ozone and chronic mortality, despite the overwhelming weight of evidence from other studies. This study is based on data that has not been made public or verified by independent scientists. Would you agree that that is not the best way to proceed, and that is not the best way to make decisions?
I do think that a lot of us are troubled that important decisions are made based on data that's not publicly available. And I'm a little surprised that that hasn't been resolved before now. The government has funded many of these studies. It's surprising that the data are not available to outside researchers. And again, these data sets are so enormous that there's just different ways of looking at the data. And maybe Dr. Dickerson has more familiarity with it, but I think we would all benefit from having public availability of data that are used to set regulatory and other requirements.
Okay, and Dr. Dickerson, would you agree with that?
I'm not really comfortable discussing EPA's policy. I don't work for the EPA. But I would indicate that if you're going to ask people to evaluate ozone science, that you would expect all of them have written peer-reviewed scientific publications that would be cited in criteria documents or science assessments. I don't think, how would you, that would forbid me or my colleague Sam from serving the EPA.
You don't want to exclude anybody who's been an expert on it. On the other hand, you don't want to have a biased source that might have a vested interest in coming up with a predetermined conclusion either. But let me ask you and Mr. Homestead a related question, which is you've got the EPA's Inspector General currently reviewing potential conflicts of interest and a lack of impartiality among the Clean Air Scientific Advisory Committee. Don't you think that we should maybe wait until we see what the Inspector General has to say before we issue too many more regulations that might involve conflicts of interest and a lack of impartiality? And Mr. Homestead?
There certainly are legitimate issues that have been raised. I don't know anything about the IG investigation, but I do think it's good for, I'm a little uncomfortable about some of these issues because I'm not as familiar with them, but I do think it's good to have all of these things aired publicly so that we really understand more about the data on which these decisions are made and who it is that and what interest they may have.
Okay, thank you. Dr. Vandenberg, the person you report to is Dr. Kenneth Olden, who's director of the National Center for Environmental Assessment at EPA. Dr. Olden has said, quote, studies used in the formation of regulations should be subject to data access requirements regardless of who funded the study, end quote. He has followed this recommendation as head of the National Center. Do you agree with his statement?
Thank you for that question. This is a complex area because some of the studies that we're referring to here include private individual medical information. And so I think what's essential is to assure the protection of individuals' private.
I'm not talking about classified or confidential information, but just in general, do you agree with Dr. Olden's standard?
That the data should be available,
yes,
that are appropriately
yes, correct,
excluded? Of course, yes.
Okay, good. Thank you, Dr. Vandenberg. Thank you, Mr. Chairman. Yield back.
Thank you, Mr. Chairman. The final question then will come today from Ms. Edwards.
Well, Mr. Chairman, thank you, and I actually hope we do go to a second round of questions. Dr. Dickerson, my question is for you. A key to some recent findings is the discovery of a chemical signature that differentiates emissions from oil and gas activity from those given off by automobiles, cow manure, or other sources of volatile organic compounds. The finding was fundamental to the conclusion that oil and gas activity contributed about 55% of the volatile organic compounds linked to unhealthy ground-level ozone. Can you please tell me whether this chemical signature will help determine how much ozone levels are due to things like gas wells versus the impact in a metropolitan region such as ours, where we experience high levels of ozone, bad air quality, and we're always at the top of those lists? Can you tell me how you think that chemical signature could help in making determinations for EPA and using its flexibility in setting ozone standards?
Yes, happy to. I have to say, wow, I didn't expect such technical questions. This is absolutely true that oil and gas operations have a characteristic signature of isomers of pentane and other hydrocarbons that allow you to differentiate those from tailpipe emissions. And these are indeed useful investigations. Ozone can be made in a power plant plume that has one chemical signature. It can come from tailpipe emissions that has a different. Forest fires are not as efficient as internal combustion engines, but they can make ozone as well. They have yet another chemical signature. And all of these are indeed distinguishable by hydrocarbon ratios as well as other trace gases and aerosols.
So let me just ask this, and maybe this goes to Mr. Vandenberg. Wouldn't it be the case that if we're able to make those distinctions in the source by this chemical signature, that could enable us to make adjustments in a way that would accommodate some of the interests of some states that are claiming, or regions that are claiming to produce ozone that they don't have any, where there's ozone present, they don't have any control of, and we might actually use the EPA could use its regulatory authority to make some distinctions in those regions, so we really do get at the heart of the problem?
Thank you for the question, and again, to reinforce the comment, I think with the advancements in science in terms of looking at chemical signatures, that's the kind of information that I think helps inform the decision-making downstream in terms of what is a natural event, what is the source of the contributors to the ozone that's in the air. And I think that's a very important type of information that can be brought to bear.
And Mr. Altman, I probably should direct this really to you, because it's the work of the scientists at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado that you're representing that actually helped to reach this conclusion. How do you think the discovery can clarify some of the questions that we have about background ozone levels and contribute to EPA's research and review process?
Yes, I'm familiar with work that you're discussing. Most of it took place in the Front Range of Colorado, Utah, and in Wyoming. Personally, I'm not sure that this is that important a factor in determining the role of background ozone. One of the things I think that's misinterpreted about background ozone, it isn't that often that background ozone itself leads to a violation of the standard, but it gives very little room for regulatory control to bring ozone levels down to the standard. In other words, it's very unusual for ozone to be 60 parts per billion in what would be considered background conditions, but as you push up close to 60 parts per billion on the background, it is very difficult to find any regulatory scheme that will reduce the result from photochemically produced ozone either over a region or locally to be controlled and meet the standard. I think that's one of the things that needs to be considered, and background ozone itself is not the violation of the standard by the background, but how difficult it makes it to control.
I think I understand that. I guess my point, and we can get to this at some other point, I suppose, is that knowing, for example, that 40% is coming from that background ozone that we don't have any control of, would that allow then the EPA to exercise somewhat more flexibility in those areas in order to have ozone settings that actually reflected the things that we could have control over? Anyway, with that, I think my time has expired. Hope we get to a second round.
Thank you, Ms. Edwards. Many of us would actually really appreciate the opportunity for a second round. However, the nature of what we do being what it is, a couple of us have to go to another committee where they're holding votes for us now. So unfortunately, we won't be able to take that opportunity this time. However, I'd like to remind the members that we can follow up with written questions, and several of us will intend to do that. I thank the witnesses for your valuable testimony and members for their questions. And as I said, members of the committee may have additional questions, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and written questions from the members. With that, the witnesses are excused, and this hearing is now adjourned.